Alright guys, so this is the video for section 11.7, and in this video we're going to talk about volume and surface area of cones. Okay, so first of all, let's kind of introduce what surface area is. Okay, so surface area is the total area of the surface of a three-dimensional object. Okay, so when I say surface, I'm thinking it's like the outside shell. Okay, so think of like if you were going to paint a three-dimensional figure. You would just paint what's on the outside. That would be the surface area. Okay, so when we're doing surface area, we find the base and then the lateral surface. Okay, so the lateral surface is the entire surface area minus the base or the bases. Okay, so if this would be the area of the base right here, and then the rest of it would be the lateral surface. Okay, so just think it's the entire surface area without the bases. A net, you guys played with nets back in middle school. It's just a 2D flat pattern of a three-dimensional figure. So like think of like cubes. So think of like all these different squares that when you fold it up it can form a cube. That would be a net of a cube. Okay, and then slant height is just the slanted distance from the apex to the base. Okay, so think of like a cone, and you have slant height for things other than a cone. A cone looks like this. Okay, the height of this cone would be from here straight down perpendicular. This would be the height. Okay, the slant height would be from here on the outside to the base. Okay, so it's literally slanted. All right, so let's look at the volume of a cone first. Okay, so the volume of a cone is just 1/3 area of the base times height. Now, if you recall, all bases of cones are circles, so the area of the base is always going to be pi r squared. So the volume for every area of a cone is just going to be 1/3 pi r squared times height. Okay, so let's look at this. So the volume's going to be 1/3 pi r squared times height. And this is our height straight up and down, not our slant height. Okay, I probably should have gone back to here. And usually when I talk about slant height, we use like a cursive L generally to represent slant height. All right, so 1/3 pi r squared times h. Okay, so let's plug stuff in. So 1/3 pi, my r squared is just 2.2 squared. My height straight up and down, this is straight up and down, is just 4.5. All right, so if I simplify this a little more, I have 1/3 times pi times 2.2 squared is 4.84 times 4.5. Okay, and if I take this, this, and this, and I put it in my calculator, I just get 7.26 pi. This would be my exact answer. And then, of course, if I wanted to put it in my calculator, that's roughly 22.8. And we're talking about volume, so that'd be centimeters cubed. That would be my rounded answer. All right, so let's look at the next example. Okay, example 2a. So once again, we're finding the volume. So the volume is 1/3 pi r squared times h. Okay, go ahead and work this one out on your own, then we'll go over it, and then we'll do some more examples. All right, now when you plug in 7 for your radius and 13 for your height, and you do some math, you should get roughly 212 1/3 pi, or if you put pi in your calculator, that's roughly 667.1 inches cubed. All right, let's look at this one together. Okay, so the volume of a cone is 1/3 pi r squared times h. Okay, so if I look at this, here's my radius. So my radius goes right here. Now, I want to draw it to your attention that this 8 is talking about this right here. Okay, this is not the height. This is the slant height. Okay, so what we need to do is I'm going to take this right triangle and use Pythagorean theorem to find the height. Okay, so 5 squared plus h squared equals 8 squared. So 25 plus h squared equals 64. So h squared has to be 39. And so h then is the square root of 39. Okay, so that's going to be what I'm going to plug in for my height. Okay, so my volume is 1/3 times pi times 5 squared times square root of 39. And since we have a square root, it's going to be an ugly number. I'm just going to go ahead and put it all in my calculator. All right, so if I put all this into my calculator, I get roughly 163.5, and that is meters cubed. All right, similar cone problems. These are the same as other shapes as far as setting up the proportion. So what I'm going to do is I'm going to find the scale factor in one-dimensional space. Okay, so the scale factor in 1D is 8/2, or you could do 2/8, whichever you want, which reduces to 4/1. Okay, so then the scale factor of three-dimensional space, right, because volume's three-dimensional space, has to be 4/1 cubed, which is the same thing as 4 cubed over 1 cubed, which is the same thing as 64/1. Okay, and now that I have my scale factor in 3 dimensions, I can just set up a proportion. So I can say 64 is to 1 as, so 64 is the bigger number, so the volume of the bigger number, 484 pi is to, I don't know, we'll call it A for area. Okay, from here we're going to cross multiply, so 64A equals 1 times 484 pi, divide by 64. So 484 divided by 64. That would be my A is equal to 7.5625 pi, or if I include pi, 3.76, and that is centimeters cubed. All right, I want you to go ahead and do this one on your own. You guys should be pros at this by now, and then we'll go over it. All right, so you should have gotten the scale factor in one dimension is 3/1, or 1/3, whichever way you did it. And then you cube that to get it in three-dimensional space. So 3 cubed over 1 cubed is 27/1. Okay, and if I put 27/1, the bigger volume is on top. That's the one we don't know, so we're going to call it A. The smaller volume is on bottom. 15 pi, we cross multiply. You should get area is 405 pi feet cubed. All right, so now let's turn our attention to surface area of a right cone, okay? And it's pi r squared plus pi rl. So let me explain what we're doing. First of all, this L stands for slant height. All right, so all we're doing is this pi r squared here, that's just this circle here. That's the base. Okay, so it's finding the area of this. And then this pi rl right here, that's the lateral area, which is everything but the base. So we're finding those two things and adding them up, essentially, is what we're doing. All right, so let's look at this example. We want to find the surface of the surface area of a right-hand cone. So surface area equals pi r squared plus pi r times slant height. Okay, well, if I look at this, my radius is 4, so my r goes there, and there's my 4. And my slant height is 6, which goes right there. All right, so if I write this out, my surface area is pi times 4 squared plus pi times 4 times 6. Okay, so 4 squared times pi, 16 pi, plus 24 pi, and 16 pi plus 24 pi is just 40 pi, and we're talking about surface area, which is in fact area, so it would be in inches squared. All right, I want you to go ahead and do this one here on your own, and then we'll go over it. All right, so when you plug in 7.8 for your R and 10 for your L, you get pi times 7.8 squared plus pi 7.8 times 10. Okay, do a little math. You get 60.84 pi plus 78 pi, and when you add those two numbers, you get 138.84 pi. This would be the exact answer. And when you put that into your calculator, this would be your rounded answer. All right, guys, so let's do one more example. So we're going to find the volume of this composite solid here. Composite solid just means we're putting two different shapes together. Okay, so what we have is we have a cylinder with a cone on top. Okay, and if we add the volumes of both of those, we would get the volume of the whole thing. All right, so let's do the cylinder first. The volume of the cylinder is pi r squared times h. Okay, well, here's my radius. So pi times 6 squared. My height of the cylinder is 5. So pi times 6 squared is 36 times 5. And 36 times 5 is 180 pi. Okay, so the volume of my cylinder is 180 pi. Now, I'm going to find the volume of my cone, which is 1/3 pi r squared times h. Well, my radius is still 6. So 1/3 pi 6 squared, and the height of my cone is 4. So once again, 1/3 pi times 36 times 4. And 36 times 4 is 144. And then 1/3 of 144 is just 48 pi. All right, so what I need to do then is add these two. So 180 pi plus 48 pi gives me 228 pi, and that's meters cubed. Or if I put that into my calculator, that's roughly 716.3 meters cubed. And that is it.